Well, hello, welcome to Algebra 2 video notes. Today we're going to talk about section 1.1, and it has to do with patterns. Patterns come in many shapes and sizes. Patterns can be a diagram. It can come in the form of just words. It can be numbers, or in our case, it can be algebraic expressions. So we just have to look at them and decide what comes next, is how it always works out. So let's start with this picture. Everybody knows it's a triangle, has three sides. The next picture is a square. The next picture is a pentagon. And I want you to tell me what the next picture would be. Pretty simple. This has three sides. This has four. This has five. So the next one would have to have six. So we draw ourselves a nice little hexagon. So it could be as simple as just drawing the next picture in the pattern. Now, patterns have different parts to them. They have variables, which are just letters like N or X or whatever you want to use. They might have a numerical expression, and that would be something like 3 plus 5, just numbers involved. Or it might have an algebraic expression, and that would be like 3n plus 5. So it's a combination of variables and numerical expressions. So let's look at the next pattern, and we'll use these three things to set it up. So we're going to look at some toothpicks. If we arrange toothpicks in a square, there are four of them. If I do another set and add another square, and then maybe a third set to that, I'll add another square. So you can see a pattern emerging here. Now it'd be pretty easy to draw the next one. You just add another set of four. But what if I wanted to know the 25th set, or how many toothpicks are in that? So what we're going to do is learn to set it up in a chart. Our chart is going to have three sections to it. And the first part has to do with the figure number. So this is figure number 1, this is figure number 2, this is figure number 3. That also is called the input. That number, whichever picture we're looking at, that's the input. The middle column is going to be called the process column. Is what is the process to get to our final result? Are we adding 2? Are we multiplying by 6? What is the process? The third column in this particular problem is the number of toothpicks, or you can generalize it and say the output. Okay. Now, the biggest thing is this first column has to relate to the second column. You have to somehow use these input numbers, figure 1, 2, and 3, and use them in the next column. So, I'm going to look at this pattern here. I see that this has 4 toothpicks. This has 4 and 4, total of 8. This has 4, 4, and 4. Now I notice this has 1 set of 4, this has 2 sets of 4, this has 3 sets of 4. So there's kind of the process that I'm going to be using. The 1 set of 4, and then the 2 set of 4, and the 3 set of 4 gives us our total, 4, 8, and 12. Well, if I jumped down and went to the 15th and asked how many toothpicks will be in that, you would say the 15th set of 4, 15 times 4 is 60, so right away you can see the final result. But what if I didn't know which one I wanted to find, or I just wanted to give somebody else the process. So I'd use a variable in place of the input, and that would be n times 4, or just 4n for the output. So the input number has to somehow show up in the process to get your final number. All right, let's try another one, a little bit more tricky here. Let's start with a shape like this, where it's got one colored in dark, and then the next one has one colored in dark, but the other ones are not, and then the next one still has that one colored in dark. All right, so we're still going to have the same 3 columns. We have input, process, and output. Okay, oops, output. Give me that back. Okay, so let's look at that first one. I have one dark square and 3 other ones. This one I have one dark square and 5 other ones. This one I have one dark square and 7 other ones. This is figure number 1, 2, and 3. So I'm going to put those in here. Now remember, the 1, 2, and 3 have to show up in this second column somehow. So I'm going to just kind of put them in there for a minute and see how I can work around them. So I notice that I have a 1 in every column. So that 1 I'm going to add to whatever the rest of the process is going to be. The second part, now I have 3 here. To make a 3, but I have to include a 1, I'm going to look at these 2 separately in each pattern here, or in each part of the pattern. So I have these 2 plus 1 more. I have these 2 twice plus 1 more. I have these 2 3 times plus 1 more. So there's my 1, 2, 3. These 2 can be written in here, and then I add that 1 more right here. Now these 2 are written twice, so that's where I get 2 times 2, and then this is the 1 more we add on the end. Then I have the 2 3 times plus 1 more. Now let's see if our output is what the picture shows. The first one should be 4, so I have 2 plus 1, that's 4. 4 plus 1, that's 6. 6 plus 1, that's 8, and that works. I've got 4, 6, and 8 for my pattern. Now what if I wanted the 25th and I wanted to know how many squares that would be? Well, I put 1 plus 25 times 2 plus 1, so that'd be 52. So the 25th would have 52 squares in it. So using the process, the input, process, and output sets it up nicely for you so you can see the pattern and find very large numbers in that pattern. All right, let's do one with a graph. So I have a picture of a graph. We're going to count by twos, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. And what this graph is going to represent is length of fish compared to the gallon size of a tank that you need to accommodate those fish. Okay, so according to this, it has a point at 0, 2 and another one at 6, 8. So I'm going to draw this graph. So it's, if you have a combined length of 6 inches of fish, you should get an 8-gallon tank. That's what it's saying. So I'll put this in inches, and I'll write in combined length. combined. So if you have one fish that's 6 inches long, you need to get an 8-gallon tank for it. Or if you have 2 fish that are 3 inches long, a total of 6, you still need an 8-gallon tank. All right, so you go to the store and you buy 5 2-inch goldfish. Goldfish. You buy 4 1-inch guppies, and you buy 1 3-inch angelfish. So what size tank do I need, or do you need, because you're the one buying the fish? I don't like fish. I like to eat them. I don't like to watch them. So let's do our input, process, and output chart. So we have input, process, and output chart. So what we have to do is we have to get some inputs. We have to look at our chart here and get some points to put in there. So if I have a, let's say, we'll go right here, 5-inch. Let's start with 0. If I have 0 fish, they say you have to have a 2-gallon tank. That's the smallest that they make. So my first point is 0, 2. The second point I'm going to look at, let's look at 5, and it goes up to about 7. So that'd be my second point. So 5 inches of fish means a 7-gallon tank. And then let's try one more. How about 10? 10 goes up, well, it's beyond there, so that would be about 12. So 10, 12. So 10 inches of fish means a 12-gallon tank. So if I put those in here, 0 and 2. So input is 0 fish, 2-gallon tank is the smallest you can get. 5 inches means a 7-gallon tank, and the 10 inches means a 12-gallon tank. So I'm going to put gallons and then length for that first one, just so we remember what our input and outputs are. So what we have to do is figure out the process here. What's happening to go from 0 to 2? Well, the only way to get from 0 to 2 is to add 2 to it. Now let's see if that pattern of adding 2 works for each one. If I add 5 plus 2, do I get 7? Sure do. If I have 10 plus 2, I get 12. So it looks like my pattern is working. And notice that these 3 were used in this process column. You always have to use your input as part of your process. And then just see what pattern is happening there. Now, what's our total length in fish here? So 5 times 2 is 10, 4 times 1 is 4, 1 times 3 is 3. So I have 17 total inches in length. If I say 17 plus 2, that means I need a 19-gallon tank for my fish. I go to the store and they have 15, 20, and 25 gallon. I'm going to choose the 20 because I don't want my poor little fishies to be bumping into each other. So give them a little more space. So there's some ideas about patterns. Some are going to be easy where you're not going to need to set up this chart, but I wanted to make sure you knew how to set it up for the ones that are a little tougher. Okay, well, ta-ta for now. I'll see you in math class. Bye-bye.